This presentation is intended as an introduction to modern methods of construction. I hope to provide an overview of some of the different types, identify some of the advantages and disadvantages, and some possible considerations from a building control perspective. So what do we mean by modern methods of construction? It's a term used to describe a range of off-site manufacturing and on-site techniques that provides alternatives to traditional building. Effectively, it describes an approach to constructing buildings more quickly, reliably, and sustainably, and it differs from conventional construction methods such as concrete block build. In Mayo, and I'm sure a number of other counties, construction heretofore has predominantly been traditional in form, that is, concrete block, external plaster finish, solid timber floor joists, and a cut roof. Use of other construction methods such as ICF has up to now largely been confined to one-off housing. Drivers for modern methods include shortage of housing supply, skills shortages, availability and cost of materials, speed of construction, and value for money. And drivers like these are resulting in a move towards utilising modern methods of construction more. Today's discussions are therefore timely. Hopefully those of you from counties who have had a greater exposure to modern methods of construction will give us their thoughts and suggestions in dealing with them at desktop assessment stage, Section 11 requests for information, and on-site inspections. The definitions of modern methods of construction have varied over the years, but in general it can be broken down into volumetric construction, pods, panelised systems, sub-assemblies and components, and site-based modern methods. Volumetric construction is characterised by the off-site design and manufacture of three-dimensional units. They are assembled under factory conditions, typically made of timber or steel, and they're very often transported to site fitted out with their internal fixtures and fittings complete. Once they arrive on site, the units are placed on prepared foundations to form a building. Here we have an example of a building constructed using multiple volumetric units. The units are placed and fixed in position on arrival to site and result in the construction or assembly of the building within days. Pods, such as factory assembled kitchens and bathrooms, are designed to slot into existing structures. The manufacture of the pods are similar to the methods used in volumetric construction. They are typically non-structural units and are used within the structural element of the building. This method of construction involves the manufacture of flat panels under factory conditions. Unlike volumetric construction, however, the panels are assembled on site or incorporated into existing structures. They include floors, walls, and roof panels and are used to form the complete shell of the building. Here we have a panel being assembled in a factory. It's made from light gauge steel frame, which you can see here. You can see fixing brackets top and bottom, here and here. The window, which is here, will be factory fitted over here. The ends, which you can see this area here, won't be completed until it is assembled on site and any necessary fire stopping at the junctions and application of air tightness membranes have been applied. Panels can be open, that is, they can have an open side for fitting of services, insulation, etc. on site before closing. They can be closed, that is, the services, conduits, insulation, etc. are finished in the factory. And as I said, they are typically made of light gauge steel frame, timber frame, concrete or composite materials. This is an example of a building being constructed using concrete panels. They are all numbered so that they are fitted in accordance with the site plan. You can see the numbering system there. You can see the individual panel there. Sub-assemblies and components are individual elements designed to be added to structures. They can be added to traditional build or other build procedures. Examples are door sets, metal web joists, I-beam timber joists, truss rafters, pre-assembled cabling systems or prefabricated plumbing. Here are metal web joists fitted on site in lieu of solid timber joists. This provides for the easy installation of services between the ground and upper floors. Modern methods of construction also include on-site methods such as insulated concrete formwork. This is known as ICF construction. Another site-based method is thin joint masonry. ICF blocks are made of lightweight expanded polystyrene, which are hollow in the middle. The blocks are designed to interlock, and this enables easy building. Reinforcing steel and in situ concrete placed in the centre provide the structural strength of the building. Here you can see the preformed top of the EPS. This provides the interlock of the blocks. Concrete is generally poured in stages, and this is allowed to cure before rising another lift. Thin joint masonry allows a thinner depth of mortar, typically 2 to 3 millimeters compared to the traditional 10 millimeters. It results in a faster laying time and improved productivity. The method uses autoclaved aerated concrete blocks and a special adhesive mortar which cures quickly. Full strength may be achieved within 2 hours, and this enables more blocks to be laid in a day. If we take modular build as an example, some of the advantages of using modern methods of construction include speed. The construction may take place as site services, foundations and other works are ongoing on the site. There's reduced building construction times, and the effects of inclement weather are minimised as the majority of the construction work is carried out off-site and in an indoor environment. Reduced health and safety risks. A factory environment would typically have safety benefits over a site environment. Greater quality control. The factories should have a factory production control system in place. Factories are likely to be more streamlined with minimal wastage of raw material. It's easier to get workers into a factory environment than the harsher environment of a site. Factory production processes can be streamlined and repetitive, thereby increasing production and productivity. Some of the disadvantages include specialized types of equipment may be required for handling large components at the construction site. This brings its own risks. Wind factors must also be taken into consideration. The economies of scale have an effect as the initial cost is very high. From an environmental perspective, there's multiple transportation of materials from the suppliers or builders providers to the factory and subsequently to the site. And modular construction is highly engineered, so there's low tolerance allowances. Here we have a completed steel frame modular build. When it comes to modular construction such as this, how is building regulation compliance proven, bearing in mind that the system is manufactured off-site and the speed of assembly on-site? If we look at the 12 parts of the building regulations, we can see that most are affected within the floor, wall or roof panels of modular construction. We know that Part D requires the use of proper materials and work to be carried out in a workman-like manner, but how do we know that it was? Looking back at our modular built house, a steel-framed house such as this may be raised off the ground by legs and pads, which are bolted to the foundation. What is the fixing detail? What of the durability of the steel pads which are constantly exposed to the environment? Are the foundations adequate for the manner in which the building load is spread? What of the materials and workmanship of the floors, walls and roof? Is there a factory production control system? Is the system documented? What is the procedure for checking raw materials and that it meets the design criteria? Have key inspection intervals been defined? How are inspection results, tests and assessments recorded? How is evidence recorded of actions taken when control measures haven't been met? Is there a clear responsibility for sign-off at each inspection stage? Is there evidence of sign-offs at each of the key stages, the design, material specification, the release of drawings to the manufacturer, at the factory, the inspection of incoming goods, inspection of each manufacturing stage, the final inspection of the finished product, at the site, is there a site assembly plan, site supervision? Is each panel numbered or labelled so that it's clearly identifiable? Don't forget, building control can request a copy of the factory production control sheet for any panel. Is it dated? What's the panel number? What are the panel dimensions? Who checked it? Is it signed off on? And I would argue that it should include photographs showing the panel makeup. Is there a site control sheet? When the panels are being fixed together on site, what is the fixing detail? What are the DPC details and have they been carried out? What about fire stopping, air tightness membrane across panel junctions? Is there thermal bridging? Is there proof of all of these? And as before, building control can request a copy of any of the information deemed pertinent. Factory and site control records should be an integral part of the overall documentation. This is the interior of a glulam constructed house. What is the fire classification? Does it offer adequate resistance to the spread of flame over the surfaces? What about the durability of the building? In December of last year, the NSAI produced a guidance document to provide more information on the aggregate certification process for modern methods of construction. The aim of this was to enhance the certification process and to provide a clear pathway for manufacturers on the assessment process. The document guides the applicant through the assessment process. This includes building regulations and European standards compliance, laboratory test results, on-site evaluations of the as-constructed product or system, factory production inspections, quality management system verification, installation procedures, on-site inspection plan, and post-construction maintenance program. In conclusion, modern methods of construction can and do produce good buildings compliant with building regulations. But as building control officers, we need to look at the manufacturing and installation processes to ascertain compliance, and there should be adequate records demonstrating this at every stage of the manufacture and construction process. Thank you.